Hello and welcome to question 9 of June 2018's calculator paper. Jean invests £12,000 in an account paying compound interest for 2 years. In the first year, the rate of interest is X%. At the end of the first year, the value of Jean's investment is £12,336. In the second year, the rate of interest or interest rate is X divided by 2 or half X%. And our question is, what is the value of Jean's investment at the end of 2 years? So there's quite a lot of information packed in there. We're told compound interest. So straight away, I would write down our compound interest formula, which is A equals initial amount A0 times by, in brackets, 1 plus an interest rate divided by 100, all to a power of a certain number of years. So this is the value of the investment. This is the initial amount invested times by 1 plus an interest rate or rate of interest X divided by 100, all to the power of a certain number of years n. And this is absolutely key to answering these compound interest questions. So we're given some of this information. We're told an initial investment of £12,000 of Jean. So £12,000. We're told the first year rate of interest is X, so that remains as X. And we're told the first year, so we know that the number of years here is just 1. But at the end of this first year, the value of Jean's investment, which is A, is £12,336. So we've used our formula and we have just one variable here, which is X, so we can solve for X. I'm going to divide by 12,000 both sides. So 12,336 divided by 12,000 gives us 1.028. And then on the left hand side, and then on the right hand side we just have these brackets. Now these brackets are to the power of 1, so that means that any number inside a bracket is just multiplied by itself once. Because anything to the power of 1 is just itself, so anything inside this bracket just remains as it is. Look at the powers lesson on the channel, and that should make that a bit clearer if you don't understand what's going on there. So we have 1.028 equals 1 plus X over 100. So we could take 1 away from each side, which will leave us with 0.028 equals X over 100. And if we multiply by 100 both sides, we'll move this decimal place once, twice, once to the right, twice to the right. So we'll have 2.8 equals X. So there's our first year rate of interest. X equals 2.8. We can use that to find the second year rate of interest, which was X divided by 2. So second year rate of interest is 2.8 divided by 2. I'll use my calculator to prevent me making any silly mistakes. 2.8 divided by 2, 1.4. So there's our second year rate of interest. We can now use our formula again to find the second year value of the investment. So I'm just going to draw a line down here. So to find out our second year value of the investment, we'll put in the year before. Now we know at the end of the first year the value of the investment was 12,336. We have 1 plus our second year rate of interest, which we know is 1.4 divided by 100, and the number of years, well, we've had 1 year, we're now into our second year, so it's just going to be 1 more year of interest. So we can use our calculator to solve this. I'm going to do the work inside the brackets first, so I'll do 1.4 divided by 100 plus 1.014. All to the power 1, so it just remains as 1.014. So we have 12,336 times by 1.014. 1.014 is still there, times by 12,336, and that gives us an answer of 12,508.704. So there's our answer. The value of Jean's investment at the end of 12 years, £12,508, and we can make this a bit tidier because obviously we can't have 0.004 of a penny, so let's round that down and say £12,508.70. I hope that's clear. We've gone over quite a few things there. We've done powers, a little bit of algebra, compound interest formula, which is key to these sorts of questions. If there's anything that's not clear, if I could have explained anything better, please just leave a comment down below. But thank you very much for watching and keep up the hard work.